Okay. I don't know what happened to the rest of you guys. They're not coming. Right. Last week. Okay. Before I begin, all right. I know some of you asked me about quiz 9. Quiz 9 is the last one before the Easter break, and quiz 10 will be in week 12, which is the last week of the semester, right? Quiz number 10 will be in week 12. That is, I think it will be the first week of May, right? Okay. Right now, let me give you a hint, because some of you guys, hello. Some of you guys asked me about, you have the variable binomial with parameters 2 and p, right? Okay, x. So if you have a variable that has a binomial distribution 2 and p, what are the possible values it can take? It can take the values this is the PMF, right? So the possible values can be either 0, 1, or 2, right? There are only three possible values for the random variable. And what the question says is the following. It says that there are right? The question says there are n0 data points or observations with x equal to 0, n1 observations with x equal to 1, and n2 observations with x equal to 2. These are the possible values the variable can take, right? And the total number, which is n0 plus n1 plus n2, is equal to n. Okay? And the question is to find the MLE of P. Right? The question is to find the MLE of P given all this, right? Does it make it clear or not? So quiz 9 is due next Monday, the 1st of April. Okay? All right, guys. I hope this helps you to clear things up. If you had any doubts about quiz 9, I hope this helps you. Right? Okay. Right now. Right. The next thing I want to talk about is right. I just want to talk. Okay, this week we are in week 9, right, which is current week. We will talk about confidence intervals. All right. Next week, I just want to give a picture of what we are going to do in the rest of the semester, because some of you. You know, next week is week 10. We will talk about test. Right? We'll talk about test of hypothesis. Right? That's week 10. So after week 10, you have the Easter break, and when you come back, it's week 11, right? Week 11. Right, so at the beginning of week 11, you need to hand in the ARC coursework, right, which is due on the 29th of April, which is the Monday. It's the first Monday after the Easter break, okay? Okay, week 11, we will also talk about tests of hypothesis. And the final week is week 12. Week 12 will be revision. Revision for the exam, right? That's it. So these are the things, this is what is left, right? So week 12 will be the final week, okay? Right, so this week we're going to talk about more about, last week I started talking about confidence interval, and this week I will continue to talk about confidence intervals, right? Okay? So before I do that, let me summarize what I did last week. I know some of you, maybe, I don't know whether all of you were here or no. So let me summarize what I talked about last week. All right, this is the first thing I did last week. This is the confidence interval for one sample. And the first one I talked about is the confidence interval for the population mean when the population variance is known, right? And it turns out that where's my pen here? The confidence interval for the population mean is this guy here. So this thing in red is the confidence interval for the population mean when the population variance is known, right? Now, some of you ask me also, like these derivations, you know, the derivations I've described here, you will need to know them for the one sample case, but not for the two sample case. So this derivation is examinable. You know what I'm saying? So maybe I should write it down. I will write down here, this is this is examinable, right? Okay. And the second confidence interval I talked about is this one here, which is also examinable. Right, this is the confidence interval for the population mean when the population variance is unknown, right? And the derivation goes like this. This is the derivation I described to you last week, and this is what you get. This is the final answer for the confidence interval for the population mean, given that the variance is known, right? So these are examinable. And the next one I talked about was the confidence interval for the variance. This is once again examinable. So this derivation gives you the confidence interval for the population variance, right? And the final answer is this one here, right? So, okay, so it's the derivation, right? And the fourth thing I talked about last week is the confidence interval for the population proportion. This is once again examinable, right? So this uses the central limit theorem, right? And the final answer we got, is, I'll show you in a sec, is this one here, right? This is the confidence interval for the population proportion, right? using the central limit theorem, right? So the derivation of this is also examinable, okay? Right, now then I talked about confidence intervals for two sample problems, and to your relief, none of these none of what I'm going to talk about today will be examinable, right? So none of the confidence intervals for two sample problems will be examinable. Okay, so all right, guys. Okay, guys. So the first thing I talked about is when you have two samples, right? When you have two samples, so sample x1 to xm from a normal population with this mean and this variance, another sample from another normal population with this mean and this variance. The first thing I talked about last week was to find the confidence interval for the difference in the two population means, that is mu1 and mu2, right? I mean, this is useful when you have like when you are testing a new drug versus a old drug, right? And you want to see what's the difference between the performance of the new versus old, right? So you need to compare the population means, right? So for this case, I showed you last week, right? After a lot of derivations, none of which you need to know, I showed you the confidence interval. The confidence interval for mu1 minus mu2 is given by this, right? This is what I showed you last week, guys, if you may recall, right? But you don't need to know the derivation, as I just mentioned, right? Okay. All right. Now today, what I'm going to do is carry on from that. So let me see where my notes are. All right, what I'm going to talk about today is number 2. So I did number 1 last week. This is number 2 for two sample case, right? So this is right. See the confidence interval for the difference in the population means right. Okay, so you guys okay? Is it? All right. So this is we are assuming, you know, in number 1 last week we assumed that the variances are known, but in practice it's hardly the case that the variances are known, right? So in case number 2, we are considering the case where the variances are known but are equal between the two populations, right? Okay. So suppose IID with, let me use the same notation, don't want to mess it up. Okay. You see, we are assuming that the variance sigma squared is the same between the two populations, right? Okay. Okay. Right. So in this case, now I'm going to show you how to construct a confidence interval for mu1 minus mu2, right? Right. This is where what we learned before comes in, right? So the first thing I'm going to ask you is, I'll be disappointed if you don't tell me what this is. What distribution will this have? Do you guys remember this? Do you remember or not? You've already forgotten about. This will have the chi-square distribution with m minus 1 degree of freedom. Do you guys remember this or not? Yes? Okay. And, sorry, there's a squared here. This will have a chi-square distribution with n minus 1 degree of freedom, right? Okay. Now, if you add these two, right? I'm going to add these two. So I'm going to if you add these two, what distribution it will have is something I mentioned some time ago. Do you remember? What I've done is to add these two guys. So it will have, if you look back in the notes for the chi-square distribution, you will see because these two guys are independent and they are chi-square distributed, the sum of two independent chi-squared variables is also chi-squared variable with the degree of freedom summed. So m plus m minus 1 plus n minus 1 becomes m plus n minus 2, right? You follow me? Yeah? Yes? No? Don't be scared to ask any question, guys. Okay. All right. Right. Now, this implies the following. It implies the probability that, right, that let me write it down carefully. This is okay. Because this guy has this distribution, right? The probability that it lies between Can you tell me what this should be equal to? This should be equal to what? 1 minus alpha, right? Yeah, this is something I explained last week, guys, right? You remember the picture that I had in the, I don't have a copy of it here, but you remember the picture of the percentiles of the chi-square distribution, and the area between them is 1 minus alpha. Yeah? I hope you remember. All right, okay. All right, so this implies that now, if you write this statement here as a statement on sigma, or sigma squared, right? Well, before I do that, sorry, what am I doing? What am I doing? Sorry, give me a sec. I think I'm doing something silly here. Just give me a sec, guys. No, this, yeah. Let me scrap this one. This one shouldn't be here. All right. From this, we also know that. Sorry, I apologize for the mistake, but I shouldn't have written what I have written. All right. Right? We know this, right? Right? We know this. I mean, once again, I apologize for the previous slide I written, but yes. Okay. And this implies that right? Right, okay. Now, this is where the things will get tricky, but I mean, don't be bothered, because I don't expect you to remember this derivation. Even for me, this is kind of tricky. I mean, any of the derivations for two sample problems, you don't need to know. You don't need to know for the exam. This is sum. Sorry for being messy once again. Right? I know it looks kind of clumsy. It looks very ugly here, but sorry. I mean, this is what you will get. And finally, this will yeah, and the sigma will cancel, so you have this, right? And then you have mn times mn plus minus 2 divided by m plus n. And this will have a t distribution with m plus n minus 2. I know it looks pretty ugly, but if you remember some time ago that when we talked about the t distribution, one of the properties I gave you is that anything of this sort should have a t distribution, right? Because of the degree of because of m plus n minus 2, this guy here, by the property I mentioned, has a t distribution with m plus n minus 2 degree of freedom, right? Okay. Let me just give me a sec just to make clear that I haven't made any more mistakes. mn plus n, that goes up. Okay, it looks fine now. All right. So this nasty looking expression has a t distribution with m plus n minus 2 degree of freedom, right? And therefore, guys, this implies that the probability that minus this nasty looking expression, I will just put a pointer here so that you know what I'm saying, right? Is equal to 1 minus alpha, right? Okay, you with me? So this implies that the probability that let me All right, and I forgot to include this term here, t I'm sorry. I know it looks pretty horrendous by now. Anyway, so this nasty thing would be equal to 1 minus alpha, right? And if you rearrange this thing, I'm not going to do the remaining steps because it will take forever. So I just want to write down the final answer, right? The final answer will be the following. Will be the 100 times 1 minus alpha Ci for this is, it will be x bar minus y bar plus or minus t right, and then multiplied by this expression here. Right. This is the final answer, giving the confidence interval for the difference between mu1 and mu2. So let me put this in red so that you know. So once again, I apologize for the. I mean, as you can see, the math here is very complicated. That's why I don't expect you to know this derivation. But if you can understand the derivation, that's great, right? But okay, all right. So that's number 2, right? The number 3 is the following. Is the Ci This is number 3. So we are looking for the confidence interval for the difference between the population means when the variances are unknown and not equal. So what you have is the following. You have a first sample, IID, right, and okay, and you have a second sample, IID, yeah, right? So you have 2 independent random samples. but the variances are both unknown. Sigma 1 squared is unknown, sigma 2 squared is unknown. Now, in this case, how do we construct a confidence interval for mu1 minus mu2? For the reasons that are obvious from the last derivation, I'm not going to show you the derivation, right? Right? So I will just write down the answer. I will just write down the answer without showing you the derivation, okay? So is, okay, give me 1 second, I will write it down in a minute. Come on, guys, are you okay? Right? Even the expression itself is horrendous. Never mind the derivation. Right, where this is equal to Are you tired of writing this? Okay, so this is your A. Your A is given by this. So this is the horrendous looking expression for the confidence interval of case number 3, where the two populations have different variances and the variances are unknown, right? Okay. So I'll put this in a red box. Okay, this is the red box. Okay. Okay, so that's number 3. And number 4, I don't expect you to remember this. So, by the way, I know some of you guys asked me already. You need to the formulas that you need to remember for the final exam. You should go to my website. Do you know the course website, guys? I assume you know, right? You should go to the course website. You will see there's a link. There's a link that gives you the formulas you need to remember for the exam. Right? It's not more than a page long, so it's not a lot. It's not all the formulas I have given you. Okay? All right, now finally, just a minute, guys. We're not far from the end of. All right. So this is number 4. The confidence interval for difference in proportions, right? So here we have, once again, 2 random samples. Suppose right? So this is like bit like, for example, like you should take Manchester and London, right? And you want to know how many people, the proportion of people who smoke in London and the proportion of people who smoke in Manchester. So, for example, the first sample could denote whether the people in, like, you should take a random sample of 100, right? You can see whether this will be a 1 or 0 depending on whether they smoke or not. And similarly, this could correspond to the same sample or corresponding sample in London. And the proportions you would be comparing would be the proportion of smokers in London and the proportion of smokers in Manchester, right? And you want to know what the difference is between the two, right? And once again, for obvious reasons, I don't want to show you the derivation, right? But I would just write it down, right? Right? So this is the confidence interval for P1 minus P2, the difference in the two proportions. So in the example I gave you, it could be the differences in the proportion of smokers between the two cities, right? Okay? Okay? So okay? Are you with me? Okay? So these are the 4 confidence intervals. So let me just, I know I haven't shown you the derivations because if I start doing the derivations, it will take the whole day. And you probably will not like it anyway, all right? Anyway, so, all right? And as I said before, you don't need to know the derivations for the 2 sample cases. You only need to know the derivations for the 1 sample case, which we did last week, right? Okay? So just to summarize what we did today, this is the confidence interval for the difference in proportions. Okay, let me put a red thing. So this is all right, this is the confidence interval for the difference in proportion. And this is the confidence interval for the difference in population means right? This for the difference in population mean when the population variances are unknown and not equal, right, between the two samples, right? And just a minute, guys, don't go away yet. And this is the confidence interval for the difference in population mean when, this is number 2, right? When in the two samples or the two populations have equal variance, but but the value of that is unknown, right? So this is the confidence interval in this case, right? Okay, guys, and finally the one I mentioned earlier is this one. Yeah, this is number 1. This is the confidence interval for the difference in population means when the two populations have variances that are known, assumed to be known. Right? So there are 4 confidence intervals, right, in the two sample case, right? But once again, you don't need to know the derivations for any of them, right? Right, any of the confidence intervals in the two sample case. You only need to know the derivations for the one sample case, right? Now on Thursday, one thing I haven't done this week and last week is that I haven't done any examples. I told you that I promised to do 10 examples on everything. So I'll try to do 10 examples on Thursday, right, when you guys come, okay? All right, guys, see you. Have a good day. Hello.
You say we don't need to know the derivation for this two samples. Does that mean we don't even need to know the formula at the bottom? Or do we have to remember that?
I will let you know. If it is not in the formula sheet,
Then you don't need to know it.
then you don't need to know.
And I'm curious.
Yeah. Okay. You're late though. So you're already late. Yes, sir.
The last week's when we did for one sample.
Yeah.
You show the formula for proportion.
Yeah, I gave it to you. When did you do it?
I mean, yeah, the fourth.
I don't have it here, sir.
You did. You showed it today.
Did I?
You showed it. Yeah. You showed it. Like this one. I think this one.
No, not this one. No, this is the two.
Yeah, this is the one. Oh no.
Why do you want to know? It's this one, yeah. This is.
Yeah, this one. Because I thought that it's.
You were in the tutorial today,
yes,
right?
Yes. And,
Yeah.
But what we did was, I thought this is P, not X bar.
It's the same. P hat is equal to X bar. They are the same. Because remember, P is the proportion. X bar is the estimator. X bar is the estimator of P, right?
X bar is the estimator of P. It's
Yeah.
Population sample mean.
X bar is the sample mean, yeah. X bar is the sample mean, and we are trying to estimate P is the population proportion.
Yes.
We are using X bar to estimate P.
Okay.
Yeah, we are using X bar to estimate. You have a question, sir?
This is next week's.
Quiz. Thank you, man. I'll see you on Thursday. See you on Thursday, yeah. See you guys.
Sorry.
You're late, man.
I know. Sorry.
Come on. Are you guys okay? See you guys. Bye. Hello guys, you okay? You have any questions? Oh. You guys okay? Yes?